Hi, this video is going to be on these COB LED panels that I bought on eBay. I bought these after seeing them in some other videos online. I've been wanting to modernize my workshop lighting. So I do have lots of lights in this room. So I've got these under cabinet lights. I've got up there, that thing came from Costco. Behind me there is some ceiling fan fixtures. Those each have like 13 watt LED bulbs in them. So there may be plenty of lighting in this room, but there could always be more lighting. I like having lots of light, so I was thinking, you know, I'll put some COB LEDs in that'll be brighter than this under cabinet light. You know, maybe a bunch of these little modules, or maybe some of these bigger modules, and kind of come up with a 3D printed bracket, put them under there, something like that. Maybe even this huge module. So what we have here, these are 10 watts, these little ones. This medium-sized one is 70 watts. And this big one is 200 watts. 200 watts, that's a lot for an LED light. You know, you think of a normal residential LED light bulb like you might put in a kitchen fixture, or you might put in your ceiling fan fixture or your lamp, and they're, you know, like 6 to 12 watts. So this is like 10 times as much as a normal light bulb. It's going to throw off a whole bunch of heat. I don't know if it's actually going to live up to its rating or not. It actually says 1000 W on there. I don't know if that's intended to be watts or that's a part number. If that's intended to be watts, I'm saying there's absolutely no way this thing would survive 1000 watts. I'm skeptical that it's even going to survive 200 watts. What did I do with the other one? It's under there. Yeah, so we're going to try all three of these. We're going to use my power supply here. This is a Mastech HY3010. It does up to 30 volts and 10 amps. And it's got two supplies, so you can put those in series and get 60 volts at 10 amps, or you can put them in parallel and get 30 volts at 20 amps. And we will actually do that when it comes time to do the big panel. I'm going to try to destroy at least one of these during this video by giving it more amps than it's rated. Probably this one, because it's the cheapest one. And I bought a lot of them, so it's not like I'm going to miss him if he dies. So maybe you want to like watch the whole thing and spot when we kill one of the modules. If you just want to get to the results and know how hot these things get, I will put up like a spreadsheet summary at the very end that shows the results of the video. So either watch it all and see what happens, or skip to the summary, whatever you feel like doing. Okay, so I'm going to get started testing these modules. First up, we're going to do these little 10 watt modules. So you can see I've got it set up here. I've got some good heavy wires running over to my power supply, and the Fluke has a thermocouple Kapton tape to the back of the heatsink on the COB module. What I'm going to do is I'm going to ramp it up and then see how hot it gets. So let's get started. So for this little module, I'm going to go in like, let's say 200 milliwatt increments. Maybe let's do 300 milliwatts. So we'll do 3, 6, and 9. That ought to get us pretty close to our 10 watts when we get up to 9. So there, it's starting to light. 1, 2, whoops. It's more than we bargained for there. That should be about 300 milliamps. Just under 11 volts. Okay, so it's up to 44.2 and it's still climbing. To save on camera usage here, so I'm not changing up batteries constantly, I'm going to actually shut the camera off and I'm going to just let it sit here and stabilize for a bit. So maybe give it about 10 minutes and then I will be back and we will see what we ended up at. I'm going to do that for every one of these tests. So here goes. Be back in 10. Okay, it's been sitting here for quite a while, and it has stabilized out at 46.4. Let's ramp it up to 600 milliamps. Okay, there, that's a little bit more precision using the other meter. So let's see, we've got 600 milliamps, 11 volts. Okay, so we've ended up around 54 degrees. Let's run it up to 900 milliamps. Okay, here we are at 68 degrees Celsius. 900 milliamps, about 11.2 volts. What this should be, what, just a bit under 10 watts? Let's go up to 1.2 amps. That might be a little bit over the panel's rating, but let's find out what happens. Okay, it's been running for a while. 11.4 volts, 1.2 amps, a little bit over the limit on it, and we're at 83 degrees Celsius. I'm really not going to be happy until I've destroyed this module. So what we're going to do is we're going to go up. We're going to go up to, how about 2.5 amps? So I am just bringing myself a bucket of water, you know, just in case something bad happens. Well, 142.5 degrees. It's still going up. Take a quick look. The LEDs are still all lit. Nothing has burned up yet. Let's hasten this process. We don't have all day here. Let's go up to 5 amps. Now that sucker's going to get hot. 5 amps, 13 volts. This was 65 watts into a 10 watt panel. Oh! I do believe we have killed it. Look at that, we burned out some LEDs. And the temperature's going down. Oh yeah, look at here. I had the volt limit way up. I had the volt limit all the way up to 30. So as soon as that blew, yeah. I think we got hot enough that we melted the Kapton tape off the back. Down to about 12 volts. Yeah, it's not drawing very much amps. We burned out some of the LEDs in it. But cool. We destroyed it. That's what I wanted to see happen. Okay, I have this set up. So the 70 watt panel is here. It's hooked up to my big power supply. I have a thermocouple Kapton taped onto the back. Let's crank this up. We're going to start at 1 amp. See some brightness starting to come out of it. Here is 1 amp at 11 volts is about 11 watts. And I'm going to let it run for about 5 minutes. Then in 5 minutes we will cut the camera and maybe let it sit for another 10 unfilmed just to stabilize out the last couple degrees. Okay, that's been about 10 minutes of settling time. We're settled around 33.6. Let's crank it up to 2 amps. Okay, so the temperature seems to have stabilized around 42.3, 42.4 or so. Let's crank it up to 3 amps. Oops, that was a little overshoot there. Back down to 3. And we'll give it a little bit. Okay, we seem to have stabilized up at about 53.5 degrees at 3 amps. Let's crank it up to 4. Okay, I've let it settle for a while. We're up around 63.7, 63.8 degrees. Let's run it up to 5 amps. Okay, here we are stabilized at 5 amps. 74.7 degrees, well, 74.8 degrees Celsius. So that's about, about 60 watts. Let's ramp it up to about 70, which I think will be around 5.7. We'll give it our usual 5 minutes. Okay, we seem to be stable, pretty much around 87.7 to 88 or so. This is with the full wattage of the panel, about, let's call it 88 degrees Celsius. Okay, the next one of these to try out is this 200 watt panel. 200 watts is going to be a lot. I'm probably only getting to around 180, 190 using just one of the channels on my power supply, but that's going to be plenty. It actually says 1000 W on there. I don't know why it says that, because obviously it's not a 1000 watt panel. That would be ridiculous. Even 200 watts is probably a bit ridiculous. But let's give it a shot and see what happens. I'm going to ramp this up at about 3 amps for each try instead of 1 amp, just because it's going to take a long time to get up to about 15 amps or so, which is where we're going to want to top this out. So let's bring it up to 3 amps. So that's what, about 35 watts we're doing right now. We'll let it sit here on camera for 5 minutes. Okay, it's been going for a little over 10 minutes now. It's at 46.6 degrees Celsius. Let's crank it up to 6 amps. So that's now a solid 72 watts. Let's let it sit here and see what it does. Okay, 6 amps. We seem to be holding around 70.2, 70.3 or so. This is getting pretty hot. If I was to mount this as workbench lighting, it's probably too hot to use 3D printed fixtures. I don't think my PETG would be holding that well at now 70.4 degrees. I'm going to crank it up to 9 amps. Okay, 9 amps, 12.5 volts. So that's what, 102, 105 watts. That's quite a bit of wattage. Let's let it sit here and run and see what it does. Okay, it looks like we're about to run out of battery in the camera, so I'm going to cut this particular take a little bit short, change out the battery, come back in 10 minutes or so, and we'll see where we topped out at. Okay, so it's actually been running for a good 20-30 minutes. We're up to 97 degrees. So 9 amps, 12.3, that's what, 105, 110 watts, somewhere in that range. Let's crank it up to 12 amps. That's as high as that is. Maybe we need to, let's bring our voltage limit up. We're actually topped out. So what we're going to have to do is figure out how to slave these together. Put them both in. Will be parallel. I don't know if it actually connects them internally. I think I'm going to actually have to run jumpers across. Still recording, still recording. Okay, we bridged these together, and we should be good to go. So if I set them each to 6, does that mean we're doing 12? Okay, we seem to have stabilized around the neighborhood of 117 degrees. It kind of goes up between 117 and 118. It's kind of bouncing around a little bit. This is, about 12 amps, almost 13 volts. Let's call it somewhere in the neighborhood of 150 watts. Now let's bring it on up to 200 watts. I'm going to go do some math. Okay, according to my calculator, we are at about 205 watts. We'll just bring it down a hair. That way we can't say we overtax the panel. We should be within 200 watts now. Let's let it sit here and see how hot it gets. Okay, I think we've pretty much settled in at the steady state here, which seems to bounce around the 145 to 146 degrees Celsius range. Yeah, that's about where we're at. It's up to 146 now, but I've seen it kind of dip and go back up again. So I'm going to call this panel functional at 200 watts. I had my doubts when I started this experiment. I didn't think it could possibly handle that kind of wattage and that kind of temperature without a larger heat sink or a forced air fan or something. You take the thermocouple loose. It's actually certainly hot enough I can't touch the thing, but I did want to kind of take it and aim it down so we could see just kind of how much light comes out of a 200 watt COB panel. So I'm not going to aim it at the camera because I mean, you know, I don't know, maybe it's actually bright enough to damage the camera. There's quite a bit of light there. You know, here's the room without, here's the room with. Whoa! Yow! That was hot. Turn on my normal under cabinet lights so you can see what the difference is. There's without the COB panel. With the COB panel, certainly this is too hot for me to use it in this configuration. You know, 145, 146 degrees Celsius is pretty darn hot. Yeah, and you know, certainly it's bright enough you don't actually want to look at the thing. So anyway, there you have it. The panel actually does handle the wattage it was rated at. All of the lights are still lit on the front. None of them have burned out. I'd say we've given it a good solid 20 minutes worth. I'm ready to turn this down. There, and I'll flip it around just so you can see all the lights are still lit. So interestingly, if you watch Big Clive's video, he certainly had an issue where some of the lights were brighter than others. And you know, he theorized the thing wasn't going to make it to its rated capacity. Mine, it just doesn't really look that bad. I mean, I don't know if maybe I got a better panel than he did, or you know, I didn't look at this prior to cranking it up, so maybe, you know, it kind of settled in as it ran up to full temperature. I don't know, but this here is this is less than 100 milliamps. There you have it, 200 watt COB panel. Let's let it sit here and cool down for a while. Okay, so I've plotted out all of the results here on this Excel spreadsheet. At the top we have the little module, the middle we have the medium-sized module, and down here at the bottom we have the big module. So let's see, rated capacities. For the first one, you know, we got to around 10 watts. Here at 900 milliamps, we got to 68 degrees Celsius. That's not bad. You could almost imagine a 3D printed PETG mount being able to handle that. You know, I'd like to keep that down to 65 or less, but you know, we're not far from it. Certainly somewhere between the 600 and 900 would be a pretty safe spot there. 70 watt panel, to get to its rated capacity, it runs pretty hot, 87 degrees Celsius. To be safe on that, I would probably want to go somewhere between like 3 and 4 amps on it. Between 35 and 48 watts, you know, mid 50s, low 60s, somewhere in that range. The big panel, it does get pretty hot. So here at, let's see, to get in 65 Celsius range, I think we'd have to shoot for about, maybe about 4.5 amps. Yeah, to get its full rating down here, 145 degrees Celsius, that's really hot. I think you'd either need forced air cooling on that or attach it to a bigger heat sink. So for me, for my workbench lighting, I think what I'm going to do is I'm going to shoot for around 3.5 amps on the medium-sized panel. I will mount 4 of these under my workbench, and I will build some custom constant current supplies. I think I will tie it to a Raspberry Pi so we can operate it from Alexa, or we can operate it from Google Assistant or something. That'll all be the subject of a future video. So we'll be aiming for around 40 watts on that and under 60 degrees Celsius. Seem right to conclude the video without just trying to see how much amps I could put through this panel. So I brought it out here to the outside just in case there's an accident. And I'm going to crank it up to as high as the power supply will go, which should be on the order of 20 amps. Again, we've got the thermocouple hooked up, taped to the back. Let's crank it up. Okay, yeah, we need to raise that up. Okay, so now, right now we're at about 20 amps. Just max out both these dials. So about 20 amps, about 14.5 volts. It is actually raining pretty good out here. Up there. It just failed. So let's take a look and see what we've got. So we lost about a quarter of the LEDs. You can see occasionally they'll flicker a little bit in there. Let me bring this. There, you can see some of them trying to function. This is actually quite warm. So anyway, that's it. It got to about 180 degrees Celsius. There was some blue smoke coming off of it. And we burned out, some of the LEDs. You can't really tell how many of them actually fried, because I suspect that a lot of them are hooked up in series in one of these banks. So just one LED going out can probably take out a whole group of them. And certainly there's something wrong with the rest, because even though we've got this cranked up, it's only drawing 200 milliamps at this point. So there you have it. We didn't catch it on fire. I tried to catch it on fire. This was about the best we could do. Alrighty. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.